We have three parts in this problem. Part A, we sketch the graph of a function that has a local maximum at 2 and is differentiable at 2. Part B, we sketch the graph of a function that has local maximum at 2 and is continuous but not differentiable at that point. And in part C, we sketch the graph of a function that has a local maximum at 2 and is not continuous at that point. So let's start with part A, the graph of a function that has a local maximum at 2 and is differentiable at 2. Here, by the Fermat theorem, we know that the derivative that exists because the function is differentiable at 2 get to be equal to 0 because we have a local maximum. So this is a sketch of a graph of a function that has a local maximum at 2, and as we can see, being differentiable at 2, the graph has a horizontal tangent line at this point of tangency, which occurs, or where occurs, the local maximum. So by Fermat's theorem, f derivative at 2 get to be equal to 0. That's because we are saying that the function has a local maximum at 2 and is differentiable there. So then we apply Fermat theorem, we know the derivative get to be 0. So this is an example of that. We have a local maximum value at 2. Okay, in part B, we want a graph of a function that has a local maximum at 2 again, but now the function is continuous but not differentiable at 2. And this is an example of that. Again, we have a local maximum at 2, because if we look near the value 2, that is, we take an open interval containing 2, the highest value of the graph is the image at 2 in this case. And so we have a local maximum at 2, but the function is not, let's call it function f, is not differentiable at 2 because we have this corner here at this point that says that there is no tangent line, and f is continuous. There is continuity in all points of the domain of this function. So we have the three properties. So we have a graph where the tangent line is 0, that is, there is derivative and it must be 0 because there is a local maximum at the point. And here we have a local maximum and continuity, but we have no derivative at the point. And part C, we want a graph of a function that has local maxima at 2 again and is not continuous at 2. And that's in an interesting case because this part B is almost a solution, but we get to take the image of 2 away from the trend of the lines. That is, we put it a little bit up. And this open circle here means the image of the point is only at the point 2 is put another place. In this case, is put at this high here. And it's only for one point, but graphically we make this type of draw in order to indicate that. So we have a function that is discontinuous at 2. The image is put a little bit up. The image at 2 is put a little bit up in such a way that if we take any interval containing 2, the highest value of the function is the image at 2, in fact. So it has a local maximum. It has a local maximum at 2, and is not continuous at that point, and of course not differentiable also. So we have these three solutions to the given problem.